All right, I guess I'll record the beginning part of this. Hello, everybody. Happy Tuesday. Thank you for coming. I appreciate you being here. Today's going to be mostly a work day, so I'm going to have some time for Lab 5. Just a minute. So if you're done with Lab 5, then work on homework 1. I haven't seen any submissions for homework 1 yet, so I assume there's a lot to do. So yeah, we'll do Lab 5 for a bit. I'll talk about Lab 5 as well. We'll do some review of object-oriented programming. I'll record that bit. And then we'll have an activity that I always like to do at the end of object-oriented where I give you some statements and you're like, is this true? Is this false? So we'll do that in groups and then we'll talk about it as a class. And then any remaining time, we'll just have to work on the things and I'm available for help.
Yeah, real quick, do we have any
Okay, so let's come back. We'll have some, we'll do some review and talk about things for a little bit. And then once we finish that, then the rest of the class time, you can work on stuff. Because as of now, once we finish Lab 5, then we're pretty much done with object-oriented programming. Of course, there's also always other things that we can talk about. But now you've got the basics to do a lot of these things in Java and do a lot of kind of advanced setting up of classes and working with objects. So just to kind of remind you of where we started all the way back with the terminology of what's a class, what's an object, what's a field, what's a method. Do you remember that? So hopefully we've come a long way since then because now we're working with these more advanced topics. We talked about whether fields should be public or private. We talked about what is a constructor. Why can we have more than one? Why would we need more than one? We talked about setters and getters. We learned about toString. We learned about equals, all of these special words that classes can use. We learned about packages and visibility. Like there's public, there's private, there's package visible, which is just blank, and we can have protected as well. And then from there, we went to inheritance, where we can extend classes. So now that we can talk about classes, we can extend them. And we talked about inheritance, what sort of things get inherited, and how do we redefine a method to get it to do something different here rather in the superclass. We talked about what if we don't want to implement a method, and we want to leave it for later classes. There we have abstract methods, where a class that has an abstract method means that the class itself has to be abstract. And then subclasses have to implement any abstract methods, or they've got to be abstract themselves. Then we talked about interfaces, where if we want some classes to use these specific methods, like for payable, the interface is a method contract. And so like if we want to, I did not update this slide okay, this bullet point doesn't make sense. But if we want circle to be stretchable, and to be a shape, then we can have an interface that has the stretch method. We use interface with implements. We also talked about generic types, which is where we leave off in Lab 5, where we define them with T or more. To use it throughout the whole class, we put T after the class name. To allow subtypes, we can use the wildcard. We could also, we could have T to say T extends something. So like in lab 5, you're going to have T extends student to say that the thing in this section is going to be a type of student. We can also use generic types in a method and just put it before the return type. Congrats, we did it. We learned the basics. Okay, so the thing we're gonna do now is, if I can find the tab. Okay, so on Canvas, there is in object-oriented programming, there's a document T or F. And T or F has all of these, it has, let's see, 18 questions. And so I would like you to work in groups, and I've got markers if you want to write your answers up on the board and talk about whether each of these ones is true or false. And I've got the solution. So if you talk about it in groups, and then we'll come back and discuss it as a whole class. Sounds good?
Good. Good.
Cool. All right. I don't want to do it. If we had a more open room, I would maybe have us go to like one side or the other, but I don't think that. But with the way that the desks are set up, we'd just be tripping over everybody's stuff.
No, I mean, if we got something like that, stop us, how are we gonna?
Should we try it?
Let's try, let someone trips on a desk, like, and hurts himself.
Okay, let's not try it this time. Let's. Okay, let's vote by show of hands. How do I want to do this? Okay, yeah, let's vote by show of hands. So all methods in an abstract class must be abstract. Who votes for true? No votes for true. Who votes for false? Hooray! Why?
Because they don't have to be abstract, why would they?
You only set a method to abstract if it's like something that you want to like be able to change the method online.
Mhm.
You want the method to
Right. Yeah. Yeah. If you want something that so you can then override it. The thing like for employee, what's a good example for employee? Like name. You could make that like final so that it doesn't get overrided. Or you can just make it you just like define it and then leave it alone. Okay. An abstract class may provide constructors. Wait, hold on. This is false. An abstract class may provide constructors. Who votes for true? Who votes for false? Okay, why do you think it's true?
Who are you asking?
Anyone who thought it was true? Do you have an example where an abstract class has a constructor?
Yeah, so like, you can just provide a default constructor for a shape. It doesn't need to have like any real implementation. But that's all I got.
Okay, yeah, Jane?
Start the employee class was abstracting at a constructor.
Yeah. Yeah, employee. Awesome. Yeah, no, I'm messing up all the numbers. An abstract class can declare instance data. Instance data is like a field. Who votes for true? Who votes for false? Why do you think it's true? Or what example can you give?
I feel like everyone raising their hands may pressure someone not wanting to vote for the answer they truly believe.
You just gotta be secure in your opinion.
That's true.
Yeah. Mm-hmm.
And then, they can be inherited.
Mhm.
and then-
Yeah. So like employee again, right? Like an employee has a name, and all that other stuff. Yeah. Okay, an abstract class can extend another abstract class.
True, contrary to popular beliefs. Yeah.
Who votes for true? Who votes for false? Why do you think it was false?
I don't know, I haven't gone to the instance like that.
I think there is an example. So a circle isn't abstract.
The employee one,
Mm-hmm. Employee is abstract.
the two abstracts, entire,
And what's the other one?
no, pretty much. That was last three, a long time ago.
Lab 4. Does anybody know what the other abstract class was? Yeah, it's hourly employee.
Oh,
So hourly employee was abstract, but it extended employee. So wait, let's pull that back up. Lab 4. So we had employee, which is abstract, and hourly employee, which was also abstract. Okay, can an abstract class extend a non-abstract class? Okay.
Can you repeat that? They were talking about like this very.
Number 5, an abstract class can extend a non-abstract class.
That's,
True.
that's true.
Yeah, I don't see any reason why it shouldn't. You could decide at this point in the hierarchy, there are things that maybe you're extending from a non-abstract class, but you decide, hey, at this point, there are things that I want to leave for later in the hierarchy. That's fine.
Yeah, why not?
Okay, number 6. Is an interface an abstract class? Who votes for true?
Oh, yeah, 11.
I know, I heard it. Who votes for true? Who votes for false? Congratulations. That's the correct answer because an interface is not a class. And so we can add whatever adjective we want here, but that still does not make an interface a class. And abstract is just the modifier that is associated with class. Okay, can an interface declare instance data? Can an interface have a field? This is one in my solution that I have a link to. Honestly, going into this, I thought this was true. But
Life is one big class.
you're always learning things. Okay, so okay, look, I've clicked on this before. Can an interface hold any instance variables? Any variable in the interface will be public, static, and final. And so, oh, okay, so the static is the linchpin here. So you can, when we're in a class, you can have a static field. That means that you can access that field without creating an instance of that class, right? So the instance refers to when we create an object from the class. And because the interface variables are by default static, then this is where the terminology thing comes in. It's technically not an instance variable. It is a variable that is public, static, and final, but we just can't call it an instance variable. So So this is officially false, but only because of the word instance.
Is this gonna be on the test?
No. Okay, number 8, any method in an interface must be public. Who votes for true? Who votes for false? Okay, a few votes for false. This is number 8. Let me look at the solution. Any method in an interface must be public. So I also have a link here and it says it's true, but let's see. What should I Google here? Interface methods public.
I look, you don't trust Google searches anymore, though. If I were you, I would use Google. The search results have become loaded.
With like AI stuff. I mean, it also depends on what you're searching for.
That's true. We should just be very careful.
Yeah.
Stop using AI now.
JLS. What's JLS? That's okay. So according to the Oracle documentation, so the methods are implicitly public. And so we can specify public after the fact, but that's redundant. But yes, implicitly. So it's true. Okay, number 9. All methods in an interface must be abstract. Who votes for true? Who votes? All methods in an interface must be abstract. Who votes for true?
Yeah.
Who votes for false? Why are you voting for false?
Like, interfaces aren't really abstract. So,
They have default methods.
or like, they have a default method, but like, all of them have to be. Wait.
So, yeah, so this is like this is like a bit of a logic question. So it's asking if all methods that an interface implements, do they all have to be abstract?
No.
The answer is no, because default methods exist. So this is false.
Wait, what? Can you check it out today? Number 9?
Okay. So interface all methods abstract. So
I think it's a reliable source. A lot of Java programmers getting together and just compiling all the
so for the documentation, let's see, that doesn't take me to the documentation. No, that doesn't get me.
That's right there. Every method that created in the body interface is implicitly abstract.
Implicitly, but you can have default methods. So you can have hold on, let me find it. You can have a default method in an interface. And thus you provide implementation for it.
So that's not abstract?
I don't,
Personally, I think the wording on this question is a little bit off.
yeah.
Just look for those, requiring.
Okay. Any more discussion on number 9? Okay, number 10, an interface can have no methods at all. is this possible? Who votes for true?
Oh,
Who votes for false?
I abstain.
All right, and the answer to this is true. So they're right. You don't technically have to. Like I can go, let's make a new test.java. There's an interface. It doesn't have any methods. Okay. Number 11, an interface can extend another interface. Who votes? Number 11, an interface can extend another interface. Who votes for true? Who votes for false? Yeah, it's true. All right, number 12, an interface can declare constructors. Who votes for true? Who votes for false? Why is the answer false? Yeah, you don't instantiate an interface because an interface is not a class. That's false. Okay. Can a class extend more than one class? Who votes for true? Who votes for false? There's a lot of people voting on this side of the class. This is false. Because, do you have a question?
Yeah, the reason is Java single
Yeah.
model of class creation.
That is correct. Yeah, because Java does not allow multiple inheritance. So we can't extend from two classes at once. We can only extend from one class at a time. That's fair. Yeah. Okay, number 14, a class may implement more than one interface. Who votes for true? Who votes for false? Okay, let's discuss. Why do you think that? Someone who voted false. Why do you think? It did, because it didn't work. I mean, that's fair. Someone who voted true, go. Yeah, so because interfaces are kind of our way around multiple inheritance, to provide these method in multiple classes. So this is actually true. If you want to implement more than one interface, you just separate them by commas. Okay, number 15, a class may extend one class and implement one interface. Who votes for true? Who votes for false? We saw this in like circle or rectangle, where it's extend shape and it is stretchable. No, I do not. I feel like that would not be conducive for student learning environment. Anyway, number 16, an interface may implement some of its methods. Who votes for true?
Which one?
For number 16.
False.
When you're saying implement like a method, are you saying so?
Yeah,
As
my
method?
initial reaction to that is just negative.
Right, so implement meaning not just the method signature.
Submission. That's false. My gut instinct just tells me it's false.
My solution says true. Remember default methods.
Yeah, I know, we pick it up, we take.
Default methods has implementation.
Yeah, but that's a sum.
Yeah. So a default method is sum. If you have one default method that you provide implementation for, then this would be true. As long as there is an example of an interface that has a default method, then it's true.
What I'm kind of getting from this whole thing is that everywhere where Java sets a rule, there's just like an edge case because they made a way to circumvent it as well. This is kind of confusing.
Kind of. Okay, number 17. All methods in an interface must have a void return type. Who votes for true? Who votes for false? Why is it false? Yeah. Say that again. Yeah, because you just provide a method signature. Like in my test, I could say like, I can say like int add. That's not a void return type. That's an int return type. So this is false. Okay, and then number 18 is like truly kind of a trick question because we never went over this at all. Do we think object is an abstract class? Who votes for true? Object is an abstract class. Who votes for false? Okay. So I like how this question has answered here closed 11 years ago. So there's a Stack Overflow link which has you okay back there?
Yeah, those guys are harassing me. You guys are all harassing me.
Okay, so the answer to this is that it's not abstract, mostly because there's methods that really matter that we want to be able to call. So the answer to this one is false. Okay. How's this sounding? Cool. Hopefully this was a good exercise to kind of, because now that you know stuff, figuring out the rules. Yeah.
So is this like our?
So there will be some true false questions in the final. There is a final. Yeah, the final exam. Yes. Yeah. Yeah, so on the final, there are some true false questions. They're probably, some of them may be tricky, but like not as tricky as, like if I ask a true false question, I will expect that you know the answer. Okay.
I feel like I have much more understanding of how that class is interfacing.
Great, I'm so glad. That's the point.
It's like the bare bones of Josh.
Yeah, so now that you know object-oriented programming, you can apply the language to other languages that also do OOP. It may not be exactly the same terminology, like, but yeah, the setup is similar. So like Python does OOP. So I think they may have made some updates to it since I was last looking into this. But Python I think it's encapsulation, like it's not entirely private. But it does still have like, you can have a class and you can have methods, you can have fields. Right, because there's much more, like there's more setup to, like, you know what you're getting into, you have object oriented, and that's like baked into the language. With Python, you can have object oriented, you can also do just scripting, and you don't have to get into that. Yeah. Cool. Any other questions? All right,
Yeah.
so we've got maybe 20 minutes or so for the rest of the class. So if you have not finished lab 5, please finish lab 5 by the end of class. That's due tonight. And then if you are done with lab 5, work on the homework, because the homework is due next Tuesday. Next Tuesday. Yeah, so thank you all for coming. I will continue to see you, but I'll end the recording in a moment. And so next time we're gonna look at linked lists. So we're moving on from like how to do things in Java specifically to building things now that we've got that structure and knowledge, building things with the code that we've learned.
Oh.